In this video, we're going to talk about how to determine the volume of irregular shapes, and that is 3D shapes. So we're going to determine the volume of this irregular shape that I've drawn here to the left. And our first step we want to do to find that volume is we want to cut the object into smaller objects that we know how to find the volume of. So when we look to the left here, we can see that we have this kind of box up here. We have a big triangle piece right here. We have a small rectangle here on the top of that dotted line, and we have another one below. So we can split this into 4 pieces, and actually if we think about it, there's also a big piece back here, and it will run like a full rectangle there. It's kind of hard to imagine that piece. So let's redraw these. So first we have our box. And that's labeled number 1. And we say it's 1 inch tall. We know that the length is going to be 4 inches. We can see that from this measurement down here. And the front of it is going to be 2 inches because it matches up with this 2 inches down here. Okay, so our next thing we have is our big triangle piece. And looking at our picture, we can see that it has a depth of like 3 inches, a height of not just 4 but 5 inches, because we have our 4 inches to the top of here, and we have to add an inch to get that extra box on, so that's going to be 5 inches. This is shape number 2. And then we know this is 2 inches out front. So shape number 3 we have is that little box. And we can see here it tells us it's 2 inches tall. It is going to be 2 inches deep. And we know that because we have a 2 inch here, and we know the whole length is going to be 4 inches. So that means that if we have 4 minus 2, we have 2 inches left. And we know the height is going to be 2 inches because that's given to us here. And the same with our width. Okay, now our 4th shape is another box, or rectangular box. And you don't have to necessarily draw these to scale as long as you put your dimensions right on them. So looking at the picture, it gives us that this is 2 inches, the height is 2 inches, and the depth is going to be 4 inches. And that is box number 4. And lastly, we have the box number 5. And it is a little taller than the rest of them, so I'll draw it that way. And we can see that its height is going to be the 4 inches, because it's essentially like this thing made of part 3 and 4, except for it doesn't have that chunk missing out of the front. So it's going to be 4 inches tall, 4 inches deep, and 2 inches wide, because it's going to line up with our triangle piece and the small box on top. So now that we have all of our pieces separated, we need to find the volume of the individual small pieces. So we have piece 1, and to get the volume of piece 1, since it's a rectangular kind of box, we know it's length times width times height. In our case, that gives us 1 times 4 times 2, and we'll get 8 inches cubed. Looking at piece 2, we have our triangle. So that's going to be 1/2 of our base times our height, And then we have our depth. Now, the difficult thing about this is we have to remember that our base is the triangle portion, and our depth in that's going to be our 2 inches. So, when we do that math, we'll have 1/2 times 3 times 5 times 2. We do that math, we're going to get 15 inches cubed. For piece 3, we have another box, so that's just going to be length times width times height. And that's 2 by 2 by 2, which will give us 8 inches cubed. Piece 4 is another box, so length times width times height. 2 times 4 times 2 give us 16 inches cubed. And piece 5 is our big portion, and that's another rectangular box. Length times width times height is 2 times 4 times 4, which will give us 32 inches cubed. So now we have all of our pieces. Our last step is to add up all those volumes to get the total. So if we add these up, we have 8 plus 15 plus 8 plus 16 plus 32. And if we do our math, we should get 79 inches cubed. So that is how you can determine the volume of irregular shapes by kind of cutting them up into different pieces that we know how to take the volume of.